Howdy. Okay, we're ready for part 2 of the primary structure module, protein purification and analysis. This section is put into the primary structure unit because we take advantage of the chemical properties of a protein sequence in order to separate it from contaminating proteins in our purification. And so what we're going to cover in part 2 is listed here as a bullet list, and then we'll break down the bullets one by one in upcoming videos. So we'll be talking about how environmental conditions like pH and temperature can affect a protein's stability during purification. So we're going to have to respect the fact that proteins are folded stably at physiological pH and temperature, and respect that and hold those as close to their functional state as we can while we separate them and purify them. We'll define in this part an assay, which is a test to assess, that's the word where the word assay comes from, to assess whether or not you have your protein and how pure it is. And it's used to quantify a protein during purification. It takes advantage of certain specific chemical and binding properties of your protein, and it also is quantitative. So that's an important feature about assays, and we'll cover that in this video. In upcoming videos, we'll talk about fractionation procedures that separate proteins from other molecules in a mixture, and then we'll talk specifically about the fractionation procedures salting out, chromatography, including ion exchange chromatography. We'll separate proteins based on their size and their binding abilities. And then we'll also separate proteins by electrophoresis, which takes advantage of the charge and size of a polypeptide. And in some cases, some specialized types of electrophoresis take advantage of their net charge at a specific pH. So we'll talk about isoelectric point. We'll also talk about ultracentrifugation, which is a way to separate very large macromolecules, such as the ribosome, which you might remember is separated based on its sedimentation coefficient, and that's done by ultracentrifugation. So we'll talk about that at the end of part 2. Okay, we're going to start this part by defining an assay. Remember, an assay is a test that assesses the presence and abundance of your molecule, in this case your protein. And this is one type of assay. In fact, this is an enzyme-linked immunosorbent assay, or ELISA assay. And there are actually different subsets of ELISA assays, and you may have heard about this when you have been learning about the types of rapid tests for the presence of coronavirus antibodies. In this example of an ELISA assay, we're looking at the immobilization of a primary antibody, or the first antibody, onto a solid support. And of course, this is schematic. The devices are much smaller, and if your antibodies don't really look like this. But here's your antibodies, which are going to recognize your favorite protein, the protein that you're trying to purify. So step 1, you immobilize that specific antibody that was generated to your protein on a solid support. In step 2, you add your protein mixture. Now that could include your proteins, which are the green teardrops here, but typically it's also got other proteins around. So if this is a blood sample, you'd have serum albumin in addition to the virus, let's say. And so your protein will be recognized by the immobilized antibody from step 1. There it is, your protein bound to the immobilized antibody, and this is after washing, I might say. So we washed away any of the other serum components if you're looking at a blood test. And at this point, you add a secondary antibody, typically a commercially available antibody, which is covalently linked to a well-characterized enzyme. Importantly, an enzyme that has a colorimetric reaction to indicate its presence. And in this way, we can layer that secondary antibody with its covalently linked purple enzyme to it, and only those immobilized sections of your assay plate, which has many of these wells with the immobilized tan at the bottom and your antibody, only those antibodies that are engaged with your favorite protein, that green teardrop, will actually engage the secondary antibody. And then you wash again so that you have your secondary antibody and the enzyme attached to it only present in those samples that are immobilized to the sample plate and where your primary antibody, the red antibody, is engaging your green teardrop protein. Okay, after you've washed, you then assay or assess the presence of the covalently linked enzyme, because that's the only thing that's going to light up a change in color. Your protein didn't do it. Neither of the two antibodies can change color. So you've got to use this trick of an enzyme, a well-characterized enzyme that has a substrate that could be colorless, or it could be one color, let's say yellow, and then when the enzyme reacts with it, it turns orange or dark brown in some cases. And when that happens, you see a color change on your sample plate, and you know that that sample of blood actually had the virus in the case of a rapid coronavirus test, for example. So that's just one example. And there's a video of the ELISA assay posted on eCampus, so you can watch this again with someone else teaching you in a slightly different way.